In this video I have one final example of an expected value calculation. I'm going to use problem number 34 on page 342 from the text. It's about the Connecticut Lottery. And I know from past experience that this problem here is a great example of what would be a real stumbling block for a lot of folks because they just don't have a clear idea of what the probability distribution looks like. So here's what the problem says in part. It says, in the Cash 5 lottery in Connecticut, a player pays $1 for a single ticket with 5 numbers. 5 balls numbered 1 through 35 are randomly chosen from a bin without replacement. If all 5 numbers match, the player wins $100,000, and the probability is given. If 4 numbers match, the player wins $300, and the probability is given. And if 3 numbers match, the player wins $10. And also the probability is given. It says compute and interpret the expected value of the game from the player's point of view. Let's take a look at the list here. We can use that for our probabilities. I'm going to use list 1 for the probabilities associated with the different outcomes. And the thing that's important to see here is that there's basically 4 outcomes that we need to be concerned with. The outcome where they would match 5 numbers. And so in that case, the probability associated with that would be 1 divided by 324, 632. And I'll just store it in there. It shows us, scientific notation, but it has the full precision. You can see the value right there on the screen. The next one is the probability associated with matching 4 numbers, and that's 1 divided by 2164. The next one is the probability associated with matching 3 numbers. That'd be 1 divided by 75. And then the last one that I need to put in here is the probability associated with matching 2 or fewer numbers. In other words, that's the probability of losing the game. And we're not explicitly told that in the problem. It's assumed that we can calculate it by doing as follows. We would take 1 and we would subtract the total of the other 3 probabilities. So we need to have 1 divided by 324, 632. And then we have 1 over 2164. And then we have 1 over 75. Just press enter, and now that probability is saved there as well. Now, as far as the cash flow, it's from the perspective of the player, and the player pays $1 to get into the game, and they don't get the $1 back if they win. So in every case, the cash flow is in view of the fact that $1 has been surrendered to play the game. So if they match 5 numbers, they're supposed to win $100,000, but because they paid $1, they're actually receiving a net cash flow of $99,999. And if they if they match 4 numbers, they're supposed to win $300, but again, they paid $1, so they actually are winning $299. If they match 3 numbers, they win $10, but again, because they paid $1 in, they actually are winning $9. And then if they lose, they're out their $1, so that'd be -1. And at this point, we can then calculate our expected value. So again, we'd go to list 3, and we're going to make list 3 equal to the product of list 1 and list 2. And then to find that expected value, we'll use a cum sum on list 4 here. I just keyed in the wrong command. I got to clear that. I need to go to ops. Cum sum on list 3. And so down there at the bottom, you can see the expected value for this particular game. So to interpret that, I would say that on the average, if a player or if a person plays this game many, many times, on the average they can expect to lose 42 cents on the dollar every time they play. So they pay $1, and it's like you give $1 and you end up with 58 cents back. So it's definitely a losing proposition. Anyway, I hope that helps. Please study this carefully and try to match the result with your own work.